Hey guys, this is Mrs. Brookshire. This is the last factoring video, and what we're going to do on this one is, it's pretty simple as you're learning these types of factoring, and they're all like the same. So I think sometimes what's difficult is when they're all mixed up, and you've got to figure out what kind of factoring you have. So keep in mind, like all the different things we've talked about, like counting, looking at the number of terms. Always take out a GCF first. So we'll talk about that as we work through these problems. Okay. So the first question you have, so it says factor completely. When you get a final answer, make sure it's completely factored, because sometimes you'll factor and then you'll end up having to factor again, and also get you back to the original. All right. So when we look at number one, there's two terms. There's no GCF. And you're going, oh, those are perfect squares. But what's the problem with number one? You don't have a difference. You've got a sum of squares. You cannot factor a sum of squares. So when you can't factor something, you're going to say that it is prime. That's what we say when we cannot factor something. Okay? All right, number two. We have three terms. There is no GCF. This is a type 1 trinomial because there's no number here. So we're going to put two parentheses for y squared. We're going to write y and y. And then what multiplies to be 36. So we've got 1 and 36. But we're also trying to get a 15. We have 2 and 18? 3 and 12. Oh, I think that's it. Some of y'all may have thought about 4 and 9. So it is 3 and 12. And then my signs should be plus and plus. And positive times a positive is positive 36. And when I add that, I do get a positive 15. Okay, number 3. We again have a trinomial. There's no GCF, and there's no leading coefficients of 1. So we're going to put x and x. We need things that multiply to be 6, but will combine to give 3. Well, when you look at these, there's no way I can get a 3. And there's no way I can get a 3 here. So this one is also prime. Prime means we cannot factor it. Okay, the next one, I have two terms. There's no GCF. And I see perfect cubes. So we're going to do the cube root shuffle. So you take the cube root and you put it down. Square the first. Square them both. Change the sign, multiply together, and square behind. Okay, so we noticed that this was perfect cube, so we knew our little cube root shuffle song. This trinomial, we factor trinomials. When you do the cube root shuffle, you can never factor that again. Okay, so that's prime. That trinomial is always going to be prime. Okay, let's look at number 5. Is there a GCF? No. How many terms are there? 4. 4 terms, no GCF. I am more than likely going to factor by grouping. Okay. So what can you take out of the first? You take out an A. What will be left? 2A plus 1. Put your minus sign. We can take out a 4. What's going to be left? 2A. Don't forget, when this is a minus, you have to change that to the opposite, plus 1. So when we factored by grouping, when this was a minus, you had to remember to change that last sign to the opposite. Now, I have a 2A plus 1 is common, and I'm left with an A minus 4 when I take those out. So 4 terms, no GCF, grouping. Okay, number 6. What can I take out? I can take out a 2, and I can take out an x. So I'm going to take out 2x. And what's going to be left? 2 into 32 is 16. Take out an x, you have left 4. 2 into 2 is 1. Take out an x, so it's going to be minus 1. You are not done, however. If you look at what we have left, that is a difference of perfect squares. So we're going to have to factor this again, and that 2x will come down eventually. So when you do a difference of squares, you take the square root of this, you write it twice, and you take the square root of the second term, you write it twice, and your signs are plus and minus. Carry down the 2x. Guess what? We're still not done, because look what this last term is. That is also a difference of squares. This you can't factor again because it's a sum of squares. But this you're going to factor to be 2x, 1 and 1, plus and minus. And we're going to carry down the 2x, and we're going to carry down the 4x squared plus 1. And that is our final answer, because finally we cannot factor anything else. So we took out the GCF. We realized we have a difference of perfect squares. We took the square root of this, rewrote it twice, square root of this, wrote it twice, plus, minus. This is the difference of squares again. So we have to factor that again. Everything that we've pulled out or can't factor again is part of the answer. Okay, let's go to number 7. GCF? Nope. Trinomial with a leading coefficient of 1. So we're going to do x and x. Okay, so what things multiply to be 75? 1 and 75, 3 and 25, 5 and 15. Okay, we need to somehow get a combination to get 10. So we're going to use 5 and 15. Now, what are my signs to get positive 10? Well, we're going to make the 5 negative and the 15 positive. So not only do those combine to give you a positive 10, they multiply to give you a negative 75. Are we finished? Yes, because neither of those can be factored again. Okay, number 8. You're saying GCF. No, you see perfect squares. You're thinking, okay, difference of squares, but guess what? That's not a difference. This one is prime. You cannot factor a sum of squares. Number 9. GCF. No. Again, I see perfect squares, and this time we do have a difference. So when we factor this, the square root of that's 3x. The square root of that's 4. And my signs are plus and minus. And we are finished with that one. Okay, next one. GCF? No. So we have a type 2. One thing on this is when you see these perfect squares at the beginning and the end, so when you do the 9, you have 1 and 9 or 3 and 3. I would always try the 3x and the 3x with the perfect square part. This is 1 and 4 and 2 and 2. Again, I would try the 2 with the 2. And when you check, that's 6x. And when you check, that's 6x. And yes, those will add to B12, both plus. So don't forget, another way you can write that is 3x plus 2 squared. Sometimes you'll see them write it like that. Rewrite it because there's 2 of them. That's actually called a perfect square trinomial when that happens. So whenever you factor and you end up getting 2 of the same factors, and this kind of looks like perfect square, and it's a trinomial. So that is a perfect square trinomial. And we are done with that one. Okay, number 11. GCF. Your answer is no. And it is a type 2 trinomial. So for 2x squared, I'm going to write 2x times 1x. Or you could just write 2x and x. Okay, 36. My goodness, there's all kinds of things to give me 36. 2 and 18, 4 and 9, 6 and 6, 3 and 12. Oh my goodness, you're like, well, which one do you pick? I think I'm going to start with the 4 and the 9. I mean, it's really guess and check, okay? I cannot put the 4 here because I have a 2, so I'm going to put the 9 here, and then I'll put the 4 here. Let's see what happens here. That's 9, and that's 8. When I multiply 9 times 1, because I'm checking the middle term. These 2 have to multiply to be this. These 2 have to multiply to be this. And to get the middle term, you multiply here and you multiply here. These will not give me 27. Okay? I cannot change these. Okay? Because I can't put the 4 there. So 6 and 6 is not going to work because I can't have the 6 with the 2. Let's try 3 and 12. I mean, again, this is trial and error. The 4 and the 9 is not going to work. I can't have the 6 in here with this, so that's not going to work. So let's go try the 3 and the 12. So I'll put the 3 here and the 12 here. Let's see what happens. That's 3x, and then that's 24x. And that's it, because that's going to give me a 27. Whoops, I'm sorry. And both my signs would be minus. Minus and a minus. Okay. So there are some things on when you do a type 2 that will kind of help you to do some elimination of some of those. Okay. So we knew we couldn't use the 6 and the 6 because we can't have a 6 in with the 2. We did 9 and 4, but you couldn't switch those and put the 4 with the 9. So then I just jumped to here. I usually start with the ones that are closer together. For some reason, they tend to work. I'm not saying that's always true. All right, number 12. There is a GCF. You can take out an x. What will you have left? X minus 2. And that's it. That's all you can do. All right, the next one, we have another, no GCF. So we have another type 2 trinomial. So for that first term, that would be 5x and 1x. And then for 26, we could either do 1 and 26 or 2 and 13. I think I'm going to try the 2 and the 13. I'm not going to put the 13 here because 13 times 5 is a huge number. So I think I'll put the 13 here and the 2 here. Let's see what happens. We get 13 and we get 10. And that's going to work because I'm looking for 23. Both of these are plus. Okay, so that one I kind of knew that not to put the 13 here because 5 times 13 would be a huge number. And I only had 23. So that was kind of, you just kind of have to use a little bit of logic on some of these. Okay, 14. GCF? No. 1, 2, 3. Trinomial, it's a type 1. So for x squared, I'm going to put x and x. For 36, I need to get 30, multiply to be 36 and somehow get 13. So I have 1 and 36. Whoops. 6 and 6, 2 and 18. None of these are going to give me 13. 4 and 9, there it is. 4 and 9 will give me 13. 4 and 9. And my signs, I need negative 13, and this is a plus, so these are both minus. You cannot factor these again because that's squares, but the x is not squared. So that would be my answer. Okay, the next one is, looks like a perfect cube. Okay, check to see if you have a GCF. There is not, and those are cubes. So you're going to take the cube root and put it down. So the cube root of that is 2. Cube root of that is x, put your minus. I need to check what the cube root of 343 is. Let's see. It's 7. Yep. So the cube root of 343 is 7. So you take the cube root and you put it down. Square the first. Change the sign. Multiply together. And then when you square behind, you're going to get plus 49. Don't forget another way you could check your signs on these is same, opposite, always positive. So same, opposite, always positive. Okay, number 16. Is there a GCF? No, there is not. And this is a type 2 trinomial. So for 15, I could either use 1 and 15 or 3 and 5. I think I'm going to go with the 3 and the 5. Try that first. And then 1 and 8 or 2 and 4. I think I'll go with the 2 and the 4. Purely trial and error. Okay. So I'd always go with the middle-ish numbers is what I call them. The ones that tend to be closer together. Okay, so these two multiply to be this. These two multiply to be this. To get this, you multiply the inside, which would be 10x. The outside, which would be 12x. And lucky guess, I got it right. And both of these will have to be minus to give me a negative 22, which is correct because this is a plus. So when you have a plus and this is a minus, remember they're minus, minus, because these have to multiply to be positive 8. All right, there we go. Almost done. We've got a couple more. Next question. I do believe there's no GCF. There's two terms. So if there's two terms, it's either squares or cubes or prime. So that's a difference of squares. So what is the square root of 625? The square root of 625 is 25. So we're going to write 25x squared, 25x squared. And we're going to write plus, minus, 1, and 1. This is prime, because we can't factor a sum of squares, but guess what? We can factor that one again. And that's going to be the square root of that's 5x. Write it twice. 1, plus and minus. And then we're going to carry down that first term. Again, you can't factor that one because it's a sum of squares. So that would be your final answer. Okay? Next question. First of all, I know there's a GCF in here because 2 at least will go into both of these. But I'm thinking that 8 will go into both of those. And yes, it does. So I'm going to pull out the 8. This will be x cubed minus 64. 8 goes into 5 12, 64 times. But that is the cube root shuffle. Okay? Because these are both perfect cubes. So we're going to take the cube root and you put it down. Don't forget the cube root of 64 is 4. Square the first, change the sign, multiply together, and square behind. Pull the 8 in front. That is part of the answer. And again, this right here can never, you're like, oh my gosh, should I go factor that? It will not factor. That trinomial will not. It's prime. That would be my final answer. Check your signs if you want. Same, opposite, soap. Same, opposite, always positive. All right, we got 2 more. This one right here, there is no GCF. I see perfect squares. This might be one of those perfect square trinomials. Let's see. So for 16, you know, you can do 1 and 16 and 4 and 4. And I told you when you see that, try 4 and 4. And then let's try 3 and 3. And I'm double checking. That's 12x because it is a type 2. And that will give me 24. So then recall another way to write this would be 4x plus 3 squared because there's 2 of them. Last one. There is no GCF. There's 2 terms. And those are all cubes. So we're going to do our little song. You take the cube root and you put it down. Ooh, you know what? I think there is. If one thing I notice here, the reason why I'm questioning myself is because I'm looking and I'm seeing a common factor. So let's see if, and it is, let's see, 216 divided by 27 is 8. So you guys catch yourself. I caught myself here. I was thinking there was no GCF, but if you look at this, and when I took the cube root and I put it down, I see common factors. So if you see that, that means there's a GCF. So I can take out 27. When I do, I'm going to have left an x cubed minus 8. And now I can do the cube root shuffle. You take the cube root and you put it down. Square the first, change the sign, multiply together, and square behind. And then put that 27 in front. And that's going to be my final answer. So sometimes use a pencil when you factor. You're going to catch yourself with mistakes, okay? Just like I caught myself. There should never, like when I put the cube root down here, the cube root of that is 3, and the cube root of that is 6. So I just kind of caught myself there and realized that there was a GCF. So sometimes you may not realize that until you start factoring. Always take out the GCF first. Always, always, always. Write what's left and see if you can factor it again. So hopefully that'll help when you go through and all your factoring is now going to be mixed up. Always take out a GCF. Look at the number of terms because sometimes that'll give away how to factor it. Talk to you later.